Hello everyone. In this lecture of the Essential Calculus Problem Series, we will solve the integral of cosecant to the power of 5x dx. Let's write the integral here again. Cosecant to the power of 5x dx. In order to solve this integral, you should remember that the derivative of cotangent x is equal to minus cosecant square of x, and derivative of cosecant x is equal to minus cosecant x times cotangent x. And you should also remember that cotangent square of x is equal to cosecant square of x minus 1. Okay. If you can't remember this, you should write cotangent x as cosine x divided by sine x, and differentiate it, you will get minus cosecant square of x. If you can't remember the derivative of cosecant x, you should write it as 1 over sine x, and after differentiating you will get this. And if you can't remember this equation, you should write cotangent x as cosine divided sine x, and you will get this. Okay, we will use here the integration by parts method. In order to use the integration by parts method, we will take the cosecant square of x part from here, as we will write the integral as cosecant to the power of 3x times cosecant square of x dx. This is reduction. We will, since the exponent is here is high, we will reduce it, and while reducing the exponent, we always use this. We always take cosecant square of x part and split it from the other part, and then we will use the integration by parts method. Since we know that the derivative of cotangent x is minus cosecant square of x, we will say this part u and this part dv. And here we have, let's say, cosecant cube x is equal to u. Now take the derivative, and we will take the exponent as here as multiplication, and 3 times cosecant, and we subtract 1 from the exponent, 3 minus 1 x times derivative of cosecant x is minus cosecant x times cotangent x times dx is equal to du, and this is equal to minus 3 times cosecant, this is 2, and we have here another cosecant x, then cosecant cube x times cotangent x dx is equal to du. And again, okay, we said cosecant square of x dx equals to dv. Now, since the derivative of cotangent x is minus cosecant square of x, here we have minus cotangent x equals to dv. And let's take this and take this. Integration by parts says that if you have any integral such as u times dv, and u is a function of x and v is another function of x, this integral will be equal to u times v minus integral of v times du. Here we have the integral of cosecant to the power of 5x dx. U here is cosecant cube x, and v here is minus cotangent x, and u times v will be minus cotangent x times cosecant cube x minus integral of v du. V is minus cotangent x, du is this. Since we have minus here and minus here, this will be plus. Okay, I will erase it. Cotangent x times 3 times cosecant cube x times cotangent x dx. Okay, then the integral cosecant to the power of 5x dx equals to minus cotangent x times cosecant cube x minus integral of cotangent square of x times cosecant cube x dx. See, we know that we have 3 here. I will take 3 here. Okay, we know that cotangent square of x is equal to cosecant square of x minus 1. So I will rewrite this as cosecant square of x minus 1. And let's take this down, minus 3 times integral of cosecant square of x minus 1 times cosecant cube x dx. Then this will become 3 times integral of cosecant to the power of 5x minus cosecant cube x dx. And we will break down this integral into 2 parts, and the integral will become, okay, take this down here, minus 3 times integral of cosecant to the power of 5x dx, and minus here multiplied by minus will become plus 3 times integral of cosecant cube x dx. Since we have cosecant to the power of 5x here and cosecant to the power of 5x here, I will take this one to the left side. 4 times the integral of cosecant to the power of 5x dx will be equal to minus cotangent x times cosecant cube x plus 3 times the integral of cosecant cube x dx. Now we should find the integral of cosecant cube x dx. Actually, before this video I solved the integral of cosecant to the power of 4x dx, and before that one I solved cosecant to the power of 3x dx. You can look at the problem that cosecant cube x dx, that video. You can look at the video that we solved cosecant cube x dx, but I will show here again how to solve the integral of cosecant cube x dx, because you should see that the way that we use while solving cosecant to the power of 5x and cosecant to the power of 3x are the same. Also, if you have any odd power of cosecant x, always we use the same method and reduce the x power. And here we have a cosecant cube x dx, cosecant cube x dx. Again, we will split this cosecant cube x and take cosecant square of x and cosecant x differently. We will say that cosecant x times cosecant square of x dx, and we will use the same method, integration by parts, and again we will say this part dv and this part u. Same method. If you had cosecant to the 7, cosecant to the 9 power, they are all the same. We will take cosecant square of x dx as dv and the other part as u. Okay, now cosecant x is equal to u here. The derivative of cosecant x is minus cosecant x times cotangent x dx will be du, and cosecant square of x dx is equal to dv. Then minus cotangent x will be equal to v, and we will use again the integration by parts, and this integral of secant cube x cosecant cube x dx, cosecant cube x dx will be equal to u times v. U is cosecant x, v is minus cotangent x, then this will become u times v minus cosecant x cotangent x minus dv, integral minus v times du minus cotangent x times du. Du is this. Again, we have here a minus sign. We have here a minus sign. This will be a plus sign. Cotangent x times cosecant x times cotangent x. Since we have two cotangent x, cotangent square of x times cosecant x dx. Then the integral becomes integral of cosecant cube x dx will be equal to minus cosecant x cotangent x minus the integral. Okay, we know that cotangent square of x is cosecant square of x minus 1. Again, we will write here cosecant square of x minus 1 times cosecant x times dx. Now let's take this down. Okay, minus integral of cosecant x times cosecant square of x is cosecant cube x, and cosecant x multiplied by 1 is equal to minus cosecant x dx. Now this will be equal to minus integral of cosecant cube x dx, and minus becomes plus integral of cosecant x dx. As you see here, we have cosecant cube x dx and cosecant cube x dx. We will take this one to the left side, then 2 times cosecant cube x dx will be equal to minus cosecant x times cotangent x plus the integral of cosecant x dx. And now we need to solve this one. Okay, let's solve the integral of cosecant x dx. In order to solve the integral of cosecant x, we need to write it as cosecant x. Cosecant x is, let's multiply it cosecant by cosecant x plus cotangent x and divide by cosecant x plus cotangent x. Actually, the integral of cosecant x, cosecant square of x, and cosecant cube x, these three integrals are really important, and also the integrals of secant x, secant square of x, and secant cube x. Also important. And for the tangent function, tangent x, tangent square of x, tangent cube x, cotangent x, cotangent square of x, cotangent cube x. All these integrals are really important for you to take the trigonometric integrals. And okay, dx. Now you should know this way of integrating cosecant x dx. We will multiply it by them, and the integral will become integral of cosecant square of x plus cosecant x cotangent x, and divided by cosecant x plus cotangent x dx. And since the derivative of cosecant x is minus cosecant x cotangent x, and the derivative of cotangent x is minus cosecant square of x, we will use here the substitution. We say that cosecant x plus cotangent x is equal to u, and differentiate it. Derivative of cosecant x is minus cosecant x cotangent x, and derivative of cotangent x is minus cosecant square of x times dx. Let's make this one plus and take minus sign outside the parentheses, and dx is equal to du. Then this means that, and let's take this minus sign here, cosecant x cotangent x plus cosecant square of x dx is minus du. Then we will say this part minus du and this one u. Then the integral becomes integral minus 1 over u du. And integral of 1 over u is ln absolute value of u. This is minus ln absolute value of u, and minus ln absolute value of cosecant x plus cotangent x. Okay, now let's take this down. Integral of cosecant x is equal to this. Okay. Now integral of cosecant cube x dx will be equal to minus 1 over 2 cosecant x cotangent x, and minus 1 over 2 times ln absolute value of cosecant x plus cotangent x. And where was, oh, okay, let's take this down now. Our integral was this 4 times cosecant to the power of 5x was this, and we found that cosecant cube x dx is this. Then we will write this, and since we have 3 here, then let's say that 3 over 2 minus 3 over 2 minus 3 over 2 times here. Okay. Then the integral of cosecant to the power 5x dx. Take this 4 to the other side. This will be equal to minus 1 over 4 times cotangent x cosecant cube x, and minus 3 over 8 times cosecant x cotangent x, and minus 3 over 8 ln absolute value of cosecant x plus tangent x. And since we have an indefinite integral, we add a constant c, and the answer is this. See you in the next video.